Hello, everyone. This is Paul Rodden. I want to welcome you back to the Hydrogen Podcast. Today, we have the special privilege of talking to Parker Meeks, the CEO of Hyzon Motors, on the future of hydrogen transportation. Hyzon Motors designs and manufactures fuel cell technology for heavy-duty transport applications and integrates this technology into zero-emissions, hydrogen-powered commercial vehicles. Their low-cost, clean hydrogen infrastructure approach synchronizes supply with demand, putting clean trucks on the road faster. Now, for nearly 2 decades, Hyzon's fuel cell technology has been developed, tested, and implemented. And now Hyzon is putting this proprietary technology to work inroads in the US, Europe, and Australia. Hyzon's proprietary fuel cell technology, in-house manufacturing, and asset-light business model sets them apart and positions Hyzon to accelerate the energy transition. I think Parker has done a tremendous job navigating Hyzon Motors since he's taken over, and I'm excited for the future of the company. All right, now enough of me talking. Let's cue up the theme song, and I want to jump into this interview.
So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
Okay, welcome back. As I said, I have a special guest for the show today, and what he's going to talk about is a game changer for hydrogen transportation and the transportation industry. I'm delighted to introduce Parker Meeks. Parker is the CEO of Hyzon Motors, a global supplier of zero-emissions hydrogen fuel cell-powered commercial vehicles, including heavy-duty trucks, buses, and coaches. He brings deep strategic, analytical, and performance-driven expertise across the energy, transportation, and infrastructure supply chain to the company, along with strong tactical, operational, and organizational leadership experience. He's worked with companies of all sizes and industries to drive transformational change via growth programs, operational performance, and acquisition strategy. Now, before coming to Hyzon, Parker held full P&L responsibility for the infrastructure sector of TRC Companies, which is a design and construction management firm with extensive work in the infrastructure, water resources, and energy transition and climate change markets. And prior to that position, he was a partner with McKinsey & Company, where he was a global leader in the company's energy, capital productivity, and infrastructure practices. He also served as the managing partner of McKinsey's Houston office. So welcome back, native Houstonian. Parker, thank you so much for being on the Hydrogen Podcast. It's great to have you here.
Paul, thanks so much for having me. We really appreciate what you do on the podcast. We're excited to tell our story.
Thank you very much. Glad to have you here. So since you were announced as the CEO, which was well-deserved in my opinion, you have taken a bold approach to reposition some of the key components of the Hyzon Motors strategy. Can you give us an overview of Hyzon Motors and talk to us about the changes that you've enacted in that position yourself as the leader in the company and as a leader in the hydrogen space?
Yeah, sure, Paul. And so the core of Hyzon has always remained the same, and that is to design, develop, and commercialize, manufacture high-power fuel cell technology, right? That's centered around our 200 kilowatt single stack fuel cell system. It's the core proprietary advantage that the company brings from the 2 decades of technology development the IP is based on and what Hyzon's focused on. But you're absolutely correct that since the leadership transition in August of 2022, we have restructured the company, make the company stronger. And that restructuring was across the organization to integrate and streamline the organization, all centered around accelerating the development of that 200 kilowatt single stack fuel cell system and bringing that to commercialization right here in the US. We've upgraded our management team significantly. And you've seen some of the senior leadership hires that we've made, a lot more talented people, hires made throughout the organization, again, focused on driving operational efficiencies and driving technology development and maturation. And then we strengthened our governance and our compliance efforts, right? The company went through a very serious governance and compliance assessment. We've come out of that. We're very proud of the work that's been done, and we're really focused on driving that forward. But beyond that, we're now very focused. It's 200 kilowatt single stack fuel cell system commercialization, bringing that plant online, which we've announced second half of 2024 for the SOP or started production commercially for our plant. It's commercializing our 3 focused vehicle platforms, right? The conventional platform here in the US that's been in trial with customers since March 2022, the cabover platform in Europe, and the rigid platform in Australia, which is the base for the garbage truck, which we announced and talked about that garbage truck coming to the US soon. And as example of that, we entered it into our first commercial agreement that we've announced for the U.S. market with Performance Food Group, which is a good example of that commercialization of the fuel cell truck platforms as we've come out of our emergence. And that's, of course, 5 110 kilowatt based fuel cell trucks to start, and an additional potential 15 200 kilowatt trucks contingent on our 200 kilowatt truck trial.
Yeah.
So we're just looking forward to building around the 200 kilowatt technology as that comes to SOP and driving more commercial progress.
That's fantastic. I want to dive into the Hyzon technology, but before we do, I want to take a step back. You're a great leader in this space, and you have a very unique perspective on this next question. Would you give our audience your thoughts on the current hydrogen versus electric debate and how that's going in the trucking industry? Basically, if you were talking to a fleet operator, right, how would you sell hydrogen as being the best choice in the future of operations?
So look, I think first, just to say it from the start, we're not a hydrogen is everything and the only thing company, right? When we go in to talk to a fleet, it's always about understanding their use case, right? And we want to find, where does hydrogen compete the best? Where is it the obvious answer, and where is it the possible answer, right? So electric trucks will be there. That said, there are significant advantages for hydrogen fuel cell trucks when you have heavy loads, going long distances, and where time and utilization is a factor. So where I start simply is, how do fleets buy trucks, and what are they trying to get out of that truck? And it just comes down to one thing. They want a truck that makes money for the company, right? And fleets really fall into 3 categories. Those that max out on weight, carrying the 80 to 82,000 pound max limit that they can on US roads. For those, battery trucks are a challenge because batteries are heavy. In fact, the typical battery truck, we estimate, is between 3,000 and 6,000 pounds heavier than our fuel cell truck. That's 3,000 to 6,000 pounds of revenue, and that makes it a real problem. Second and third types of fleets either time out, meaning their drivers stop a lot, so they run out of time eventually, or they cube out, meaning they carry a lot of large light things like shoes or chips. For those fleets, it's about range and it's about charging time, right? So range is an issue for battery trucks. Most battery trucks today, when we talk about useful range, that 20% to 80% of charge before you get into concerns about cold weather, reducing range, that's an issue, versus our trucks today have 300 to 350 mile range that we expect in most of our use cases. And we have our liquid hydrogen truck that is about to go into customer testing soon that we expect to get a minimum 600 plus mile range. And then charge times, right? Charge times can be 4 to 8 hours on today's charging technology versus 15 to 20 minute, maybe 30-minute fill times, depending on how much fuel's on board for fuel cell trucks. That's all real revenue and real uptime for fleets. So let's say that you're going to solve that issue with megawatt chargers, which is often the answer. A typical battery electric truck stop in the future based on megawatt chargers to reduce charge time would take as much power as a 100,000 person town. And given our grid and our grid reliability issues, I don't see us adding a lot of 100,000 person towns where there's already millions of people where the trucks need to travel. And I'll leave the question with one anecdote that we've heard recently in a conference from one of our competitors who's selling battery trucks. And they sold a few hundred battery trucks to a customer in California. They went to the regulator and the power company and said, we'd like to permit chargers for these couple hundred trucks. And they said, you can have permits for 19 trucks worth. They said, well, when can we get the other few hundred? And they said 6 to 7 years. So it just comes down to practical adoption, right?
Yeah.
Hydrogen does the work. It can handle heavy loads. It can handle the long distances, do it in a truck that's lighter. And we will see both, but there's a lot of the market that only hydrogen is going to satisfy.
Yeah, and I agree. I think when it comes to heavy shipping and trucking, hydrogen is a great solution to that problem. So that's one of the reasons why I talk about Hyzon so much on the show, is it's a great solution and kind of that first hurdle that's getting tackled appropriately.
Yep.
And like you said, we're also in that same boat of, let's let the right application solve the problem. Right. And this is perfect. So for our audience that may be unfamiliar with how a hydrogen-powered fuel cell electric vehicle works, can you give just a brief overview, kind of the anatomy of the truck, how it works? Now, if possible, I would love to use the Hyzon, it's the HD8,
yep,
the 200, that will utilize your new 200 kilowatt single stack.
Absolutely. Yeah, so I'll try and break it down as simply as possible. And basically, when you look at a fuel cell truck, in the powertrain that makes the truck go, you've got the fuel cell. In this case, it's a 200 kilowatt net output coming out of that fuel cell system. You do have a battery. It's a much smaller battery. It's about 110 kilowatt hour battery, where some of the battery electric trucks you see out there have 700 plus kilowatt hours of battery capacity. So 6 to 7 times what we have, which is why they're so heavy. And then you have an electric motor, and you have a traditional axle on the truck today, but in the future, an e-axle will come on the truck. So It's an electric truck, right? So number one, fuel cells are an electrochemical reaction. So
Right.
in the fuel cell, hydrogen comes in with air, the oxygen stripped out of the air and reacts inside the fuel cell stack to basically strip off the electrons from the H2. That H2 goes and finds oxygen in the compartment and water is formed. So you get two byproducts basically from that reaction, electricity and water. So water is the only thing that comes out of the tailpipe. The water you can actually drink. Our people drink it from time to time. It's a little fun. You wouldn't want to drink a lot of it because it has minerals in it, but it is pure water. And the electricity typically actually goes to recharge the battery. So the battery provides primary power to the truck. When you step on the accelerator, first call is to the battery to provide power. And that's what you're going to use in normal operation is the battery. And as that battery draws down, the fuel cell kicks on to recharge the battery. And when you're going up a hill at a full load, for instance, you need extra power. The fuel cell provides power directly as well. So that's where the basic operation is an electric vehicle drawing power from the battery and the fuel cell as needed. The fuel cell, 200 kilowatts of power versus a 110 kilowatt hour battery capacity is the primary power part of the total. And that's where the optimization of a fuel cell truck comes in. It's not just a fuel cell, it's the fuel cell with the battery, with the motor, with the entire electric delivery.
I think that's just so much more of an elegant solution than, you have the people on the hydrogen side. No, it's got to strictly be a hydrogen fuel cell to power everything. And then there's the battery people saying, no, it has to be batteries. Let them work in tandem. There's a reason why batteries do work for transportation, but not at this kind of scale. Let them work together. Great solution.
Yeah.
If we can dive in a little bit further into that single stack, the 200 kilowatt fuel cell system that you did recently announce, can you talk to us about that project, where you are right now as far as commercialization and its phase, and then go into detail on why this is a game changer for the industry?
Yeah, so like our team is working hard to deploy our next generation single stack 200 kilowatt fuel cell system. We truly do believe it's going to be a game changer as it comes to full commercialization, and it is advancing significantly through the current prototyping stages. But before I go there on why is this a game changer, for the majority of the fuel cell trucks that you've seen either talked about in prototypes that are coming to market today, they're using two complete fuel cell systems to get to the same 200 to 240 kilowatts of power, right? It's two 120 kilowatt systems, two 80 kilowatt systems, two 150 kilowatt systems. You need that 200 kilowatts of power in total. And the advantages we have of having one stack, which contains hundreds of cells, right, surrounded by one, it's called a balance of plant, which is your compressors, your coolant lines, etc. We have lower weight, we have lower volume, so it fits better in the engine compartment, and we have lower cost, right, because you only have one set of BOP around it. So we estimate one 200 kilowatt versus two of our 110 kilowatt systems, the 200 kilowatts, 30% less volume, 30% less weight, 25% lower cost to manufacture. And in our early testing of our Alpha 200 kilowatt fuel cell truck, which is already on the test track, we're seeing about 20% better fuel efficiency, which is critical for total cost of ownership. And that is based on a limited amount of initial testing miles. But it's what we expect because that 200 kilowatt system versus a 110 kilowatt truck hits that optimal operating point of utilization for the fuel cell much more frequently, right? So going back to where we are, we've achieved significant milestones in our early prototyping, and we're happy to talk about the fact that we've now tested 9 single stack 200 kilowatt fuel cell systems in our US facility. Those run at B sample stage. That was our primary goal for the end of June 2023, and we just hit that. So that puts us well towards our end of year goal of 25 fuel cell systems that are tested and validated by year end, getting us to basically a pre-production fuel cell system. And that combined with having the first 200 kilowatt truck on the test track, we are excited to have that truck continue to progress, have 200 kilowatt trucks and customer trials relatively soon, and to get to commercialization through SOP of the plant next year.
That's great. Good luck. Congratulations on that. I'm excited to see more about it. And you mentioned this a little bit ago, the largest food and food service distribution company in North America, Performance Food Group, just agreed to purchase 5 fuel cell electric vehicles upfitted with your Hyzon Class 8 110 kilowatt fuel cell system, and potentially add an additional 15 FCEVs that will be upfitted with the Hyzon's next generation single stack 200 kilowatt system. I think that's going to be a great relationship for Hyzon. Would you mind talking about how that deal came about and what it means for Hyzon moving forward?
Yeah, so our entire team is excited to partner with PFG as part of their very real focused decarbonization mission. And customers like PFG are exactly what we in the industry need, right? Customers that are focused on making real impact to decarbonization, that have real goals, and that are willing to be a part of the early commercialization and the potential scale up from there, assuming that the solution works for them. So, PFG did trial the truck in 2022. They were one of our earlier fleets in the trial set. They've been a great partner to us in helping us learn together. And the agreement that we announced with them that does have the 5 110 kilowatt trucks for delivery this year, as you mentioned, the potential for 15 of our first 200 kilowatts after a 200 kilowatt trial, and then a further potential option for 30 trucks beyond that we've agreed to negotiate, assuming that the first two steps go well. That's the kind of a program that we look to put in place with all of the large fleets that are in our trial set. What's interesting about the fuel cell market and about this transition is we don't believe that we need 100 fleets or even 20 fleets to make the scale up happen, right? We need 10 or so large fleets with the same kind of a mindset to scale in this way over time, a reasonable, sustainable scale where they get experience. We scale production as we're able to, we scale fuel with our fuel partners in line with that. That's how we scale the industry over the next 3 to 4 years with committed customer partners that really want to make it happen.
So what else is coming down the pipeline for Hyzon? Are there any other deals that you feel comfortable announcing?
Well, I mean, look, we're focused on putting our high-performing zero-emission fuel cell technology in vehicles and on the road as fast as we can. We're excited about the announcements that we've made, both in the fuel cell progression, like achievement of our 9 B-sample fuel cells tested and validated in the first half of 2023. We're excited about the commercial progress that we've made. We've announced in the U.S. We've also recently had some of our customers in Europe announce putting their first fuel cell trucks from Hyzon on the road. I mean, we made some announcements as well in Australia recently on the Rigid platform, that ISO certified truck that we're so proud of coming to the US soon. So there will be more news to come, and we're excited about getting that out. But we just appreciate all the support from our customers and our partners to make it all happen.
So I did notice that you were entering into a partnership with Hyliion. I think that's the way it's pronounced.
Yep.
To join forces and integrate their advanced electrical powertrain solution. Can you give some details on that relationship and how it's going to benefit Hyzon?
Yeah, look, we're very proud and excited by the opportunity to partner with what is a great vehicle powertrain outfit in Hyliion. So we think it's a great combination of what we do well with what they do really well. And what we do well, of course, and what we do best is our 200 kilowatt single stack fuel cell system. They have been putting together CNG electric trucks. They just made some big announcements at their investor day that I was there and participated on stage with their CEO talking about our combined fuel cell truck and, putting together that fuel cell powertrain solution from Hyzon into a Hyliion truck in a Class 8 sleeper chassis, which we have not done a sleeper chassis yet, which is a very important detail of the program. We think it's going to be a really great truck. So that program remains on track. We talked publicly about that truck coming to be available publicly in terms of demonstration later in 2023, and we're excited to have that truck as another example of a great fuel cell truck.
That's fantastic. If you're comfortable with it, can we talk about finances for a moment? I was on the investor call recently, and I really liked what I heard in terms of strategy that you and your team are putting into place to take care of some of the issues that were caused previously, or at least a brief synopsis of what that plan is and how you've navigated Hyzon into a position of strength moving forward.
Yeah, sure. Glad to. So look, over the past year, as I mentioned before, Hyzon's experienced a significant restructuring and a transformation. And at the highest level, the company was doing too many things in too many places, which caused a lack of focus and some serious controls issues, right? Along with elevated levels of cash burn and capital. So since then, we've restructured, integrated, and really simplified the company. I talked about strengthening the governance as well, and built a strong foundation through that focus, which translates through to our financials. So in our earnings call, you heard us talk about our cash burn starting to come down, right? So we were running at an elevated level of 15 million of cash burn per month in Q1 of 23. That had already come down by the end of May, in April and May, to 12 million a month. So a good first step.
Yeah.
There are still elevated levels of legal and accounting expenses in that. And we talked about on the earnings call, the potential for those to continue to come down, along with all the work that we are doing with our recently joined COO, Baba Banerjee, who brings a lot of experience in global operations, global engineering from his 20 plus years that he's now helping us to drive out. So I'm very proud of the progress that we've made in the restructuring, that we are already seeing benefit to our financials, and we expect to continue to see that. And I think most importantly, it's allowed us to really focus the financial positioning of the company on the fuel cell technology and on the fastest pathway and the most efficient pathway to commercialization through trucks.
Well, I appreciate the transparency. I think everyone else does too. Let's switch gears for a little bit and talk about Hyzon in California.
Yeah.
So California's hybrid and zero emission truck and bus incentive program, HVIP, which provides up to $240,000 in price subsidies, they've created an opportunity for you to gain a foothold in the California market. Can you talk about what Hyzon is doing to help accelerate that market growth in California?
Certainly. So look, California is clearly a key target market for us.
Mhm.
They've got significant investment in zero emission trucks and infrastructure. The HVIP voucher program is one great example, and there's many other programs both on the subsidy and incentive side, but also on the regulation side. So there's also small fleet programs that actually can provide small fleets or other disadvantaged fleets well over $240,000 per truck. Additionally, on the regulation side, there's the Advanced Clean Fleet Rule that was recently passed into law that drives mandates on conversion in areas like port drayage, where we are certainly focused on Port of LA, Port of Long Beach as an immediate impact market for zero emission trucks. And that's why we've entered into multiple partnerships, both on the customer side, like with Performance Food Group. California certainly is a market that we're focused on for deployment of trucks potentially, and also with Raven SR as an example on the fuel side, where our first investment in a hydrogen production facility into one of Raven's first plants is in Richmond, California, in the Bay Area, that we're quite excited by. And that plant will also, we do expect, benefit from subsidies through the low carbon fuel standard and potentially the federal production tax credit under the Inflation Reduction Act. So California is leading the way in the U.S. in terms of real funding on both the vehicle side and the fuel side, real support for the adoption of zero emission vehicles through regulation. And we're seeing that now spread to federal programs that we think are going to be great stimulus outside of California as well, and other states that have signed the 15-state MOU to drive similar regulation standards. So other markets like ports in Texas, ports around the country, potentially other states like Washington, Oregon, we're excited about those developing, but California is certainly a strong focus for us now.
That's great. I want to talk about your hub and spoke network, and you're being a geographer at heart. I love that setup. That you're prioritizing this back to base fleet deployments that enable the strong modular nodes. Can you tell us why you prefer small hydrogen hubs over these massive hubs, these large hydrogen industrial facilities? And I would also love if you could go into detail to outline what your plan looks like for that hub and spoke model.
Yeah, and the foundation of our focus on smaller hubs to start on the production side is this is how the market's going to come to life. When you see the customer order patterns that we are articulating generically, we expect even large fleets to start with 5 to 10 trucks in their first year. They need to get the technology, learn, and then expand as they succeed in year 2 and year 3. So it could be 5, then 15, then 30. It could be 10, then 30, then 50. But it's going to take a few years to get to 100 trucks, right? And as context, 5 tons per day of fuel production, that's going to fuel typically somewhere around 125, 150 trucks, depending on their usage per a day. So our firm belief is small hydrogen hubs have real advantage because they're lower capital, lower capex projects, have much higher probability of coming online faster, not having delays. That's the fuel we need to start. And we don't need big hubs for long haul until the dispensing is ready, which likely isn't going to take several years to develop a true long haul dispensing network. We believe if you take California as the example and the I-5 and the I-99, right, two of the major freight corridors in the state, you can look up the map and identify the centers of population, right, from Southern California to the Bakersfield Central Valley up to NorCal and the Bay Area, and you can see 150 to 200 mile spacing that fits perfectly to put down small back to base hubs around smaller production to start. And then you've got a long haul network set up once those back to base hubs economically bring the first trucks to life.
I love it. I'm just getting the map going in my head, just picturing all of it. I love it. I think another thing that sets Hyzon apart is the strength of your partnerships, and particularly Raven SR. Now, we've covered Raven's non-combustion waste to hydrogen technology and their groundbreaking facility in Richmond, which I think you're a partner on for that project.
Right.
I would love to hear how Hyzon is utilizing that technology and creating a hydrogen delivery network. You kind of talked about it a little bit, focusing on California and how it's expanding up and down that coast because it's set up just within that 150 to 200 mile distance. Can you detail your 3-phase plan for California and even beyond that? What do you have cooking up with Matt Murdock?
Yeah, look, we're very excited and proud to partner with Raven and Matt and his team. That technology of being able to take waste or renewable gases, convert it to hydrogen at essentially a zero carbon fuel is a tremendous, we think, game changer to do in small scale, which is what the market needs to start and to scale and expand that over time. So partnering with Raven's also invested in by Chevron and others. We're excited to get going with the Richmond site. And the pathway from there is really quite simple. The first phase is all about where the truck's going to go with the early fleets, right? Where are the back to base operations in each part of California and other markets as they have the subsidy available to it, where we can put down fleets with the initial 5 to 20 to 50 trucks that need that scale of fuel. Raven and our other partners can put the small scale production in place in lockstep with that. And then some of those locations can scale. So some of these landfill based locations, actually, the first production may take in 50 to 70 tons per day of waste, but they can actually divert maybe 2, 3, 4 times that amount. And the footprint is actually relatively small. So you're talking about 1 to 1.5 acres for a first 5-ton per day scale plant with a pretty efficient scaling from there. So you can have single sites that can scale from 5 to 10 to 20 tons a day of hydrogen production over time. And then you also, can look at other sites around the same area as those scale. And that's really going from phase 1 to phase 2, right? Phase 2 is scaling those locations, and phase 3 is then infilling the long haul network that you've now created the bones of by doing back to base operations up and down a map. As we're now, years in the future, and we're really filling out the spaces in between the longer haul routes. So we're firm believers again of small scale production around back to base operations is the right, efficient, faster path to get fuel where it needs to go. And the flexibility, scalability of the technology helps us to scale that up over time.
That fits right into what we talk about a lot here on the show is just, treating the energy transition like an actual transition instead of a light switch.
Right.
So just building out these small hubs, really building out that infrastructure as needed, using that hub and spoke model and starting to connect communities that way. You don't have to set transcontinental pipelines for something like this. We can just build it out like you're describing. I think that's great.
Yep.
This has been an absolutely incredible conversation. Thank you so much for being here. Very appreciative of your time, the effort you put into helping create this blueprint to shape the future of hydrogen and hydrogen transportation, not just today, but I think something that will scale immeasurably in the future. Thank you so much again for being here today.
Hey, Paul, thanks for having me. Thanks for all you're doing, and look forward to putting more Hyzon trucks out on the road soon.
All right, everyone. I would again like to thank Parker for joining me today and discussing his views on the hydrogen industry. He's a wealth of information, and I think the board did a great job with making him the CEO. I'm a big fan of that decision and look forward to seeing Hyzon's growth in the future. You can check out Hyzon's website at hyzonmotors.com to see everything they have going on. Thanks again. I hope you have a great day. Take care.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.